Okay, so for this section of our unit, right, we're talking about inequalities in two triangles. And really, there's two different types of, well, there's one theorem that we're looking at, but we also have the converse, right? So this is going to be a biconditional since we're going to show that both of these are true, and these are kind of ideas we're going to use for these triangles. All right, so the first one is hinge theorem. Okay, hinge theorem. All right, if two sides of a triangle are congruent to two sides of another, right, and the included, I've talked about this word before, the included angles are not congruent, right, so kind of something we kind of threw in here, then the way this works is then the opposite third side, oh, whoops, messed up. I shouldn't say opposite. Come on. Okay. Longer third side. The longer third side is opposite. Right. Really, it just kind of goes in the same play as we talked about the other day with the opposite side is across the largest side is across the largest angle, and it kind of works out here too. All right, so the way this is, the way, whoops. If we have this triangle BOG, right, BOG, and this other triangle MAD, if it so happens for the fact that we have these two congruent sides, if we have that, yeah, this one, is congruent to like AD, but also BO is congruent to MA, right? So yes, we have these congruencies here, but uh, right, is not the same as angle A, right? These are not congruent, right? These included angles are not congruent. That means that the included sides, right, the opposite sides are not congruent as well. One's going to be bigger than the other. So in this kind of case, right, we're looking at this side OG, side MD. They're not going to be the same, right? So the idea is since angle B is smaller than angle A, then um, whoops, that's just be OG is going to be less than, in this case, MD. Right? They're obviously not the same, but even though these are congruent, the larger angles across from the larger side, right? That's kind of how it works. And that's how it works for this other one too, right? So the converse to it, it's going to be the same idea, it's kind of reverse too. So in this case, right, let's just fill this out. If two sides of a triangle congruent to two sides of another, so start off the same way, and the third sides are, again, not congruent, then the larger included angle is opposite the longer third side. Right. So yeah, really all kind of the same idea, what we're looking at, what we're trying to do. Again, we have now this triangle MINT, so we have this mint triangle, but just like before, right? Even if we have these two sides being congruent, right, the same side, obviously this one's the same as this one, right? This one, if MT and MI are congruent, but then obviously MN is congruent to itself. I mean, you can kind of tell, right? Like this side NT is obviously not the same as this side NI. And so again, just kind of goes to show just how it was before, right? This angle here is different than this angle right here. They're not congruent. But we can kind of say it kind of the same way before. So since, in this case, NI, or IN, is greater than this other angle TN, then our angle IMN, angle IMN, is greater than, oh, whoops, I'm in the wrong colors, angle TMN. TMN. It's just supposed to be. Alright. Okay. But yeah, again, so kind of follow the same idea. The fact that the larger side is across from a larger angle, that's all it really is. And so we can kind of write that even up top right here. Um, and all of this that we talked about is that the larger angle is always across the longer side. So a good keynote to kind of have as we talk about this stuff and go through it. But yeah, that's Hinge theorem. That's the inequalities section of this, right? It's very much in line with the one we had talked about before with one inequality. Now it's with two triangle inequalities.